All right, now we're going to look at practice C. And we're going to do number 1. It says, a football player runs directly down the field for 35 meters. So I want to picture what's going on. Do I even know what downfield is? No. So let's pretend I'm going to say this way is downfield. So he runs 35 meters, and this is downfield. Then it says, before turning to the right at an angle of 25 degrees from his original direction. So this is already starting to get a little confusing. So this is his original direction. So what I'm going to do is I'm just going to draw a dashed line like that. And then he's going to run to the right 25 degrees, and that's going to be 15 meters. So this angle here is 25 degrees, and the length of this is 15 meters. So now it says, what is his total displacement? Well, displacement is from where I start to where I end up. So this is not a right triangle. Okay? Now, if I learned in pre-calc or trig, if I don't have a right triangle, I can use law of cosines or law of sines. But a lot of you haven't learned that yet. So we're going to do it the same way that we did it before, and we're going to do it by components. So doing it by component, what we're going to do is we're going to draw each vector individually. So I'm going to call this one A, and I'm going to call this one B. So for vector A, it looks like this, and it's 35 meters. For vector B, it looks like this. This angle here is 25 degrees, and the magnitude is this is 15 meters. So the next step is I'm going to find the horizontal and vertical components of each vector. So it helps to have a table, so you can keep track. So I'm going to say vector, and I'm going to say the x and the y. And then I'm going to have my two vectors. I'm going to have A, I'm going to have B, and I'm going to have the resultant. And then I want to find Rx and Ry. So when I look at vector A, well, vector A is going totally to the right. So Ax is equal to 35 meters, and Ay is equal to 0. Now for vector B, it's not that easy. For vector B, this is where I start, and this is where I end up. So first I'm going to go horizontal. So this is going to be Bx, and then I'm going to go vertical, and this is going to be By. So I need to find, so I'll fill in my chart, Ax is 35, and Ay is going to be 0. Well, do I use sine, cosine, or tangent? Maybe I'm not sure. So sine of theta is opposite over hypotenuse. Now when I look at my picture, the sine of 25 is equal to opposite. So opposite the 25 is by over the hypotenuse, which is 15. So by is equal to 15 times the sine of 25 degrees. So now on my calculator, I put 25 sine times 15 equals, and then I get my answer, and it says 6.3. Now, here is the important part. When I'm looking at my picture, is by pointing up or down? It's pointing down, and I'm still using my standard Cartesian sign convention that up and to the right is positive. So when I write it here, I'm going to write that by is negative 6.3 meters. So this is why drawing them head to tail and showing the direction in my picture is so important. Okay? So now Bx is this is adjacent to the angle, so Bx is equal to 15 cosine of 25. So now on my calculator, 25 cosine times 15 equals, so it comes out to be 13.59. So I'll just say 13.6. So this is 13.6. And this is positive because it's going to the right. So now my next step is I need to add up my x and my y's. So I'm going to say that rx is equal to ax plus bx, which is equal to 35 plus 35 plus 13.6. So that comes out to be 48.6 meters. I'll just round this to 49, to two significant figures. Ry is equal to ay plus by, and this comes out to be 0 plus minus 6.3 meters. So this comes out to be negative 6.3 meters. So to find my resultant, first thing I'm going to do is I'm going to draw my picture, because the direction is important. So this is where I start. Rx is positive, so this is going to be positive 49 meters. From the head of that vector, I'm going to do the tail of the other. This one is negative 6.3. So that shows negative. See, the negative sign is in my direction there. From where I start to where I end up now, I'm going to draw a line. The tail is where I start. The head is where I end up. So this is why I'm going to draw the arrow this way. So the magnitude of this is going to be my resultant. So r is going to be the square root of rx squared plus ry squared. So r is equal to the square root of 49 squared plus negative 6.3 squared. So now when I do that on my calculator, this comes out to be, actually still comes out, so 49 squared plus 6.3 squared equals square root. Comes out to be 49.4, so it's still 49. So this is 49 meters. But I'm not done. I have to find the angle. So I'm going to say tan of theta is equal to opposite over adjacent. So it's equal to 6.3 over 49. So now on my calculator, I press 6.3 divided by 49 equals second tan, and it comes out to be 7.3 degrees. So my final answer, R, is going to be 49 meters at. Now this is the angle I measured here, theta. So that's 7. So how do I? They don't tell me north, south, east, west. Well, this is called downfield, and this was called across. Those were my directions. I'm going to say at 7.3 degrees to the right of downfield. And that's it. So again, we have to go step by step in order to do this. And you don't take shortcuts. You write everything